Good morning. Welcome to Chemical World. Today we discuss about chapter 1, matter around us. Daily in our life we'll see so many things around us, like human beings like us, your friends, parents, different objects like books, bags, tables, vehicles, many things we see, and we don't understand that why we have different things in our life, why we have different objects in our life. Not only that, we'll see some other type of things like metals, non-metals, acids, bases, synthetic, natural substances, like so many things we see, and what we call all these things. So in science these are called matter, this matter. So then what is matter? Matter means an object, matter means in a box, matter means a metal, matter means a non-metal. Then what? Matter is anything we are seeing around us is matter. So matter is defined as anything which occupies space and having mass. That is matter. Look at me. I'm occupying some of the space in the world and I have some mass. So I'm matter. See this chalk piece. It is also occupying some space and it is also having some mass. So this is also a matter. Like anything you're seeing around you is matter. The next question comes in our mind. What is matter made of? It's a very philosophical question. Many scientists gave different types of explanations for it. If you just check the histories before 1900, there is one type of definition for matter. After 1900 year, you have another definition of matter. So let me tell you a brief history of science. Before 1900, all the scientists were thought that the indivisible part in the universe is atom. So they thought that matter is made of atoms. So atom is the very smallest particle exists in the universe. One fine day, one scientist named Boltzmann, he called all the scientists of the world and he conducted a public meeting. He organized a public meeting and he addressed the gathering and said that atom is not the indivisible particle. You can divide the atom also. Inside the atom some more indivisible things are existing. Then everybody laughed at him, because in those days all the scientists believed that atom is the only the indivisible part. So they didn't believe him, at least they didn't respect him, they laughed at him. So then he disappointed so much and he went to his hotel and all the night he didn't sleep, and early morning he hanged himself. So later, after his death, after 2 years, another scientist came forward and he published a research paper also, and he was just 26 years old, and he was a famous scientist in the history of science, and he's none other than Einstein. So Einstein published research paper about the indivisible particles inside the matter, and his research paper named as Brownian motion. So the Brownian motion explained very clearly that atoms can be divisible and inside the atom some indivisible particles are existing. Then the remaining scientists started doing research work on those things, and today we know that atom consists of nucleus. Around nucleus we have electrons, which are particles, and inside the nucleus we have particles like protons and neutrons. So all these particles are very, very small than atom. So before 1900, everybody gave the definition of matter that matter is made of atoms, but today we are saying that matter is made of material particles. So I can give another statement of the matter. It is made of material particles. So in that way, matter which occupies space and having mass, or matter is made of material particles, both the definitions of matter. So we understand that matter is made of material particles. Yes, we also know that matter is having different shape, different sizes. Matter comes with different textures. If you see the human beings, we are in different sizes, different properties, different behavior, different colors. If you see the different objects, you have different sizes and different textures. So why the different objects having different shapes and sizes and the different structures? We should know. So before going to those properties to understand, first of all, you know that how many types of material or the matter we are having, and that is nothing but states of matter. Generally, we say we have 3 states of matter, or matter existing in 3 states. Number 1, solid state. Number 2, liquid state. Number 3, gas. You know that. Yes, it is gaseous state. So generally we have 3 types of states. But recently scientists have discovered that we have 4th state of matter. And that 4th state of matter is plasma. Plasma is semi-solid semi-liquid. Okay, in your course you don't have plasma state. Just for information, I'm telling you, plasma state can be achieved at very high temperatures. Like plasma states are existing at the center of the sun. As you know that sun releases huge amount of energy in the form of heat and light, and because of that our earth existing. And do you know that how the sun is releasing the huge amount of heat and light to the earth? It's only because of a nuclear reaction happening in the center of the sun, and that nuclear reaction is called nuclear fusion. And that nuclear fusion happens at a very high temperature, around 10 to the power of 9 Kelvin. So in that state the matter exists in plasma. So today scientists were they were successful to find the plasma state artificially, and they're trying to create the same type of fusion process on the earth also, so that they want to produce the huge amount of electricity to the world. Okay, coming back to the other 3 states. This is the states of discussion: solid state, liquid state, and gaseous state. Now how would you define that? Yes, this is solid, this is liquid, this is gas. Suppose, see this chalk piece. Tell me what type of state it is. Yes, you are correct. It is solid state. If you take water, which state it is? Liquid state. You're breathing. What you're breathing? Air. Yes, gaseous state. So do you have only these 3 types of materials, solid, liquid, gas, or do you have any other types of substances in the life? Yes, we have huge amount of materials. Many different types of materials we have existing in solid, liquid, gas, like table, wood, chair, all comes into solid state. Liquid state, water, petrol, oil, any other states of liquid you know. Gas, apart from air, or inside the air, we have oxygen gas, nitrogen gas. In the laboratories also, we can create so many types of gases. So in that way, we have many different types of solids, liquids, and gases. And all these are called as, again, matter. Now my question is that, how do you differentiate wood is a solid, water is a liquid, oxygen is a gas? What are the properties making them separated, making them differentiated? Yes, that we have to know. And we're going to discuss about the properties of these 3 states. Okay, now let us discuss about the properties of solids, liquids, and gases. First, see the solid. Generally, if you see a solid and the arrangement of atoms inside the solid. Observe carefully what I am doing here. Now see the liquid. Now see the gas. So what do you understand about the arrangement of atoms in solid, liquid and gas? It says that in solid the atoms are arranged in a fixed order, and between the atoms the attraction force is very strong. So atoms are regular patternly arranged, and in liquids the atoms are arranged somehow, but they have some gaps between them. That means here the force of attraction between the atoms is less. Now see the gas. In gas, atoms are not arranged in a regular pattern. Atoms are in random directions, and the gaps between them are so high. That means the force of attraction between these molecules or the atoms is very less. So the first property of what I am telling, that the arrangement of atoms. So arrangement of atoms are regularly arranged, regularly patterned, and here the atoms are loosely packed. Here the atoms are very loosely packed. Now the second property, force of attraction between the atoms. Force of attraction between the atoms is very high in solids. In liquids, force of attraction is less. In gases, force of attraction is negligible. Atoms are tightly packed, tightly arranged. Atoms are loosely packed. Atoms are in random positions, or I can say random directions. Next, force of attraction. Force of attraction is very high, or I can say force of attraction is strong. Here, force of attraction is less, weak also we can say. Force of attraction is negligible. That's why if you have a scent bottle which is covered with the cap, if you uncap the scent bottle, within seconds, in any corner of the room, if you stand, you can smell that scent, because in that gas or in the air, the atoms are loosely packed and random in direction. So very quickly gas spreads each and every corner of the room. Very quickly the smell spreads each and corner of the room. That's why you're able to have the smell. So the first property is the second property. Let me go to the third property. Third property, I want to tell you about the shape of solid, liquid, gas. Now tell me what you want to tell about shape. If you suppose think that if I have given a rectangular wooden box to you and ask you to apply the force with your hands, and you apply the force with your hands very strongly, do you think that you can change the shape of the rectangular wooden box? No. So that tells you that solids are very strong in nature, and solids have definite shape. So they have definite shape. Coming to liquids. Liquids are different shape? No. How do you say that what type of shape they have? See the board. I have taken different containers like this. Three different types of containers. and I have filled the containers with water of volume 50 ml. 50 ml, 50 ml, 50 ml. Volume is same, but see the shape of the water, because water is in liquid state. This shape is different from this shape. Say like this. And this shape is different from this shape. So it tells that liquid, like water, they will take the shape of the container. So that means they do not have a different shape. They will take the shape of the container. But volume always same. They have fixed volume. So under the liquid column, I can say that they take shape of the container. Now coming to gas. Do you think the gas have a shape? Can you challenge me whether gas is having a shape? You can't, because gas doesn't have any shape. Because gas doesn't have fixed volume. So it is not having definite shape. Okay. Now the fourth property is volume. As I told you earlier, solids have fixed volumes. Liquids have fixed volumes but take the shape of the container. Gases doesn't have fixed volumes. That is what the fourth property. Now, I will tell you the fifth property. See the fifth property. Fifth property is about compressibility. Compressibility is nothing but the capacity of compressing the object. Earlier I told you I have a wooden box to you and apply the force in all the direction with your hand to compress it. Are you able to compress the wooden box? It is not possible. So solid doesn't have that much of compressibility. So do not have compressibility. Now coming to liquid. Do liquid have compressibility? How will you prove that? Take water into a plastic polythene cover, and tie the upper part of the polythene cover, make a bag. Now if you press that bag, the water bag, with your hand, yes, you can press it. You can apply the pressure on the different sides of the polythene bag so that water is also compressed. So what liquids having some compressibility. So I can say they have compressibility. Now coming to gas. Take a balloon, inflate the balloon with the air and tie with the thread. Now you have the balloon like birthday balloons. Now if you press in different directions the balloon, you see that you can easily compress the balloons comparing to the water bag. So that example tells you that gases are highly compressible. Highly compressible. I will give another example to have more better understanding. This is a syringe. It's a syringe generally used for injections, and this is a piston. Right. Now what you do, you close the nozzle with your finger and press the piston in this direction. Press the piston. Now what you observe, yes, even though you close the nozzle with your hand, when you press the piston, yes, you're able to move the piston inside the this tube. Now fill this tube with water. Again you close the nozzle with your finger and press the piston. Are you able to press the piston? Yes, you can press the piston, but it is very difficult and it is not that much of comfortable you feel comparing to the previous case. Previous case means previous case you have only air. So in the air you have more compressibility, but in liquid you have compressible, you have but little compressibility. Now remove the piston, put a small like rectangle shaped wooden block and you press with the piston. Is it possible to compress the wooden block? Not at all. So it says that solid do not have the compressibility. Liquids have compressibility but very less, whereas gases have highly compressibility. They are very high compressible in nature. That means you can apply the pressure on the gas. So what is the advantage of this compressibility nature? One example I'll give you. You can see the in the kitchen room the LPG gas cylinder. If you the fully filled gas cylinder, if you hold it and if you move, you feel that some liquid is inside the cylinder, but it is not the liquid. It is actually gas, but it is in liquid state. That's why it's called LPG, liquid petroleum gas. So what they will do when they want to fill the gas into the gas cylinder, they will apply very high pressure on the gas. Because of highly compressible, the huge amount of gas is compressed and stored in a small volume in the state of liquid. So that is the advantage. Huge amount of gas can be stored in a small volume in the state of liquid because of highly compressible. That's why today we are having huge amount of gas in a small size of cylinders. Next, we should know about a very great nature of materials like liquids and gases, and only these liquids and gases have that nature, and that is diffusion. What is diffusion? Let me tell you diffusion of gases. You have a dhoop stick, scented dhoop stick. So the scented dhoop stick, and you lit the scented dhoop stick. Then what happens? Generally, these dhoop sticks are used for worshipping the god. So when you lit the dhoop stick, then you observe that some smoke is coming from the dhoop stick, and you can feel the presence of good scented smell. Wherever you are there in the room, in which corner you are there in the room, still you can get the scented smell of the dhoop stick within seconds. How it is happens? Because in the dhoop stick, the scent smell, which is in the vapor state, it is spreading quickly in all the directions of the room, and that is called diffusion. So diffusion is nothing but movement of particles, either gaseous particles or liquid particles. In this case, these are gaseous particles. Movement of gaseous particles quickly in all the directions in a room or in an area is called diffusion. So diffusion means movement of particles in vapor state in all directions. Yes. Another example I'll give you. Generally nowadays, because of the heavy traffic, because of the working schedules, because of the temperature, we use body deodorants. So that we shouldn't get a stinky smell from our body, we use body deodorants to get good smell from our body. And suppose you're standing somewhere in the room and you apply the body deodorant in your body, immediately the other person, if is standing in the room, he'll get the smell of the body deodorant. Why? Because the same reason, because the diffusion. The scented smell in the air diffused in all the directions, and quickly the other persons can experience the scented smell. And remember, another good point I want to tell you, the body deodorants inside, actually you have liquid state gas only. That is also the gas stored inside the body deodorant with high pressure because of highly compressibility nature. when you press, because of change in pressure between change in pressure inside the tube and atmosphere, the what you call liquid changes into gas and comes outside, and that's why you can feel that scented smell within seconds in everywhere in the room. So that is called diffusion. So like that, body perfumes, scents, the dupe sticks, all spreading their scented smell toward the room because of diffusion property. That is how the gaseous particle move in all the directions.